Hello students! The topic we will be covering in this video today is correlation versus causation. My name is Jaspal and my partner's name is Usman.
We will begin by talking about the two variables you will have. First, you will have an independent variable, which is usually expressed on the x-axis of the graph and does not depend on another variable.
Secondly, you will have a dependent variable which will be expressed on the y-axis of the graph, and it may or may not depend on the independent variable. Here we have a graph with the y-axis and the x-axis. So on the x-axis is where you would put your independent variable, and on the y-axis is where you would put your dependent variable. Now I will begin to talk about our first main topic, which is correlation. Correlation is a statistical measure expressed as a number that describes the size and direction of a relationship between two or more variables.
There are two types of correlation: a positive correlation, which is usually indicated by both the independent and dependent variable increasing or decreasing. The second type of correlation is a negative correlation, which is indicated by one variable increasing and the other variable decreasing.
As depicted by the no correlation chart, some scatter charts may have points that are all over the place. In this case, the two variables, the independent and the dependent, may not be correlated at all.
The advantages of correlation relationship are that you can measure the direction and strength of a relationship. The disadvantages of a correlation relationship would be that it cannot determine if there is a causation. Even with a strong relationship between variables, it cannot assume that one variable causes a change in the other.
The definition of causation indicates that one event is the result of the occurrence of the other event. In example, there is a causal relationship between the two events. This is also referred to as the cause and effect relationship.
Here is an example of a negative correlation between two variables. On the x-axis, we have the independent variable, which is number of fresh lemons imported, and on the y-axis, we have the total U.S. highway fatality rate.
By looking at the data presented on the graph and looking at the correlational relationship between the two variables of fresh lemons imported to US from Mexico, which is our independent variable, and then our dependent variable, which is the total US highway fatality rate. The graph tells us the higher number of lemons that we import, the lower the fatality rate goes. But that's looking at it on a correlational view. But looking at it from a causal view, we should be able to use our logic and reasoning to determine that the number of lemons we import has no actual effect on the fatality rate.
In this graph, the independent variable is the pairs of blue socks owned, and the dependent variable is the numbers of baskets made in homecoming games. The graph shows a positive correlation between the two variables.
Once again, it seems like the pair of blue socks may have an effect on the number of baskets made. Here it says the higher number of blue socks that you own, the more baskets you will make. But in reality, there is no causal relationship between the two variables. It's easy to assume causation if there is correlation. This is called spurious correlation, which means in which two variables are not related but may be interpreted as though they are. This is our citations page. Please remember to cite everything properly and cite every resource that you have used. Goodbye, and remember that correlation does not equal causation.